So, all right, I will go over the homework questions, all of them. So this will give you some idea what exactly is regression is and how to apply it. So I'm opening, so we are in this week right now, and this is chapter number 7. So you can see my screen.
Yes. Yeah.
Okay, great. So this is question number 1, and they're asking us to, they have given us a data file, and they're saying marketing professor of Gibbons College is interested in relationship between hours spent studying and the total points earned in a course. So regression is a technique we use to make predictions or to understand a relationship between two or more quantities. So if you're saying like, how does the social distancing affect on number of cases or deaths? So the only way is to collect the data and run a regression. So all the time when we do research, like if I'm working on a research topic, one of the most basic tool or the technique or the strategy or the method I'm going to use is actually regression. So the whole research, empirical research is empirical. So empirical means you take out the data, like empirically test some hypothesis, or you have some theory, you want to test that using the data. So this professor is trying to test or is trying to say that how does the hours spent studying affects the total point earned. So he asked the students, probably he asked how many hours you studied before the exam, and then he matched that answer to their actual score in the exam. So he has 2 points, one is X and Y. So in this kind of studies or this kind of relationship, we try to see the effect of one thing on another. So here this professor is trying to study how the hours of studying affect the total points. So common intuitive sense or common thinking can be like, the more you spend hours, the better you will perform on the exam. All right, yep, that's true. Well, this is the common sense, but this professor may be trying to empirically analyze this phenomena and prove that. Or maybe he will see that even if you don't study too much, you may pass. And what is the number of hours you need minimum to just make the cutoff? So to find that, you have to do the data collection and test. So this professor did it. It did like 156 student data, and here they have given us some graphs, and we have to pick which graph is the actual one from the data. So this is the data file. I will download this file. So where is my data file? So my screen is a little bit not coming 100%. I think so. This is the data file. Let me just bring down these. So when I downloaded the data file, it came out like this. Since I have done some work on this, so it's showing some last previous work. So we have two variables. We have hours spent and total points earned. So we are trying to see relationship of this on this. Like how, so we're trying to exactly see by changing one unit, how much points they earn. So the question down, it will become down to the fact that if I spend one more hour studying, how much points I can gain or lose. Technically, the relationship would be positive, and we are expecting that the more you time spend, the more you will earn. So we can find this answer by running a regression. And Excel can do that for us. Regression is mainly a linear relationship between two or more quantities. So here we have just two quantities, and one quantity is called independent variable and the other is called dependent variable. So here in this problem, first thing we have to see is what is dependent and what is independent. So hours spent by a student is an independent variable. It's independent of the points he will actually earn. But in our study, the points earned are actually depending on how much time a person spends studying. So this is dependent variable, and this is termed as Y in the model, in the regression model, and this is independent variable, and this is considered as X. There can be multiple X in the model, regression model. And this will be one Y, which we are trying to predict, or we are trying to analyze the effect of this on this variable. So the first question they're trying to ask is, what is the relationship or the shape if we draw the points between hours spent and total points earned? And we have to pick one of them. So we can actually draw this and we can select this whole data. So I'm selecting like using my keyboard. And once I'm on this corner, I'll press the shift key, right key on the arrow keys in my keyboard while pressing the shift. And then while pressing the shift, I'm going down. And if I have to select everything, I can press shift while pressing shift and then control and the down key. It will select everything. Because I'm telling you this because there can be a really large data sets. Of course, I can select and scroll, but there can be millions of rows. Like sometime you will see the data, which is very common now. So then only keyboard can actually select. To create a graph between this variable and this one, we can create a lot of different graphs. We can do a line graph, a dotted scatter plot, or we can just go to Excel and do recommended charts. So recommended charts will draw the graph between these two variables. The first variable will be considered x-axis for Excel, and the second will be considered y-axis. So I'm using recommended charts, and actually this can tell me the shape of my data. And this one, I don't know, where is that thing? Okay, this one. Yep, so we have to select which one is actually the right shape from the data or the right graph. And I can see this matches to this one. So number 3 is the answer. You got this part, Daniel?
Yes, I did.
Okay, great. So then the second thing they're asking, how does the scatter chart indicates there may be a positive, because it's increasing. So as the values of hours increase, hours are increasing, the points are also increasing. So it's a positive relationship between the two. Then comes they're asking to estimate a regression equation. So this is the thing we have to create a regression equation. The way Excel can do this pretty easily, we can create a regression equation in which we have a y and we need an intercept and a beta 1 and x. Here, the x is the dependent variable, which means our hours spent studying, and y is the dependent variable and x is independent. So a person, how much they're studying is independent of how much they earn, or how much the points they earn. But their points are depending on how much time they spend. So we have to create a relationship between x and y, and it's a straight line equation. And in straight line equation, we do remember that straight line equation is something always like this, like y equals to beta naught plus beta 1 x, where beta naught is the intercept and beta 1 is the slope of the equation. So have you guys studied this in high school or in other courses? like straight
A
line.
similar equation, but not the same thing.
Similar, like it's usually
Y
like
equals mx plus b.
y is equals to mx plus b. Yes, so it's exactly the same thing. It's um, I've just put like in the opposite order. So B is better not, or B, we can
Mhm.
say, because it's just a name to the variable. And M is the slope. M is actually the slope, which is in the above equation represented by beta 1. So technically these two are exactly the same. We can put like this is just perfectly the same thing. So we have to fit a similar equation. We can fit an equation in between here, a line which minimizes the distance from each point. So on average, there's a minimum difference overall. If we sum up the differences from each point, so we have to fit a line that overall differences is minimized between the line and each point. So some point would be on the line, and some point would be above the line, and some point will be below the line. So we have to find an equation which can be defined by the intercept and the slope. So a line will be fit here. And then this we can actually know, okay, this is the line, and we know by because the way we calculated the slope and the intercept, we know the distances of all the points from this line to each and every point is minimum. So this is the main goal. And once you have find the line, you can actually extend the line and make more predictions. And since you know the distances are minimum, so the errors would be minimum. So this is the technical goal of regression in general. In Excel, we can apply. So first let's learn how to apply regression in Excel. So we have two variables, X and Y. We can go to data, and we can go to data analysis. So this is the same thing we opened last week. So this is the thing, if you don't have in your Excel, you have to go to file and in options, and you have to turn this on, data analysis tab. So you need this tab in your Excel. So once I click this, I have this option regression. I'll press OK. And the first thing they will ask me is to select the data. So I actually practice this question, and so I can see there it's already filled. So the Y range is the dependent variable, the Y variable. In this question, they're actually telling us that X represents the hours spent studying. So this is the X, and the Y is this one, the total points earned. So points, and I just selected this. And then this is the hours spent. And then I'll check mark this labels. And we can also do confidence interval, 90%. I can do, where do I want to produce this thing? So I will actually produce this here in this cell, the output. And residual fit, we can leave this, or we can produce it. I will explain this later, but it just depends what is the question. So if we need the output or not, press OK, and we will get this output. So any questions on producing this output?
No, I got that far.
Okay, you got that. Okay, so here we have, this is the most important part. This shows us coefficients, which is beta naught. So this number is actually representing beta naught in our equation, which is the y-intercept. It says intercept. And this is the coefficient of x, the beta 1. So technically, our equation, which is, we have 8.67, and maybe they're asking us to do round your answers to 3 decimal, so we can just like this, make it 3 decimal. Oops. Okay, 64 and 0.801. So these are the two values which we need to estimate. So we have estimated these two values, and that's it. So the third question, so we have estimated the model. So once we have the model, we can put any value of X and predict a new value of Y. So if this professor is trying to understand, there's 43 and 46, but there is no 42 in there. And the professor wants to understand what is the points earned if a student has studied 42 hours. It will just put 42 here, multiply by this number, add this number, it will get the predicted answer. And that would be quite accurate actually, with certain degree of error, but a professor would know how much error is there. So it can make predictions and inferences. So the next part is like test whether each of the regression parameters, beta naught and beta 1, so these are the parameters, beta naught, beta 1, is equal to 0 at 0.01 significance level. Well, we can say that they are not 0 at this level. They are not 0. They are significantly different than 0, and this is I can see from the p-value, because at 0.000 they still exist and they are not 0. So we can reject this test. Beta naught and beta 1 are not 0 at 0.01 level of significance. All right, so the last part of this D part is how much variation in the sample values of the total points earned does the model use? Okay, how much the model actually explains the variation. So we are trying to explain the variation. The goal is to explain the variation because the model was like, so this is the model, and if you can see, so this is our data, and now we have a fitted line in between. So there's a lot of variation actually, but the model fits a lot of it, will fit, or the technically it's asking like how much error is there, and we know how much error it's like, or how much it has been explained. What is left is the error. So model explains almost 82%. So 0.82 is explained by this model. So they're asking us in percentage, so we can make it percent, and then we can make it 2 decimal places. So this is 82.77.
So the R square is the
R square is the
variation.
variation in the model.
Okay.
R square is the total variation explained by the independent variable. If there is only one variable, we say this is explained by only this one variable. And if there are multiple variables, we'll say this is explained by this.
And then for
then
E, you would plug in 95 into
into
the B
this,
equation for X.
yes,
Okay.
yep. So it's pretty simple, like we can do here, this value plus this value into 95. So we'll get this, and whatever. So we can make it 2 decimal, 3 decimal, nearest whole number. So this is our prediction. So if you see this, maybe there is 95. Oops, 95. So I'm going to sort this. Everything is messed up here because they're all in the rows, but I'm just trying to sort it. But I'm just, because we're done with the question, so it does not really matter. So there is 95. So at 95 hours, there's a whole bunch of numbers. So some students got 99, some got 78, 79. But on average, our prediction is that if you study 95 hours, you will get 85, because maybe that's like on average. So regression just find out on average, you will get this answer. So this is for question number 1. And you said you have the same problem in question number 2.
Well, question number 2 is a similar problem, so I could
Okay.
definitely figure it out. Actually, it has the what is it? What is it asking in E?
So in E, if we have to make the model and everything, so it's it's like we have to plug in the values. So
Oh, okay.
the best bargain, yeah, we have to plug in the values in the model. And it's for, all right, so maybe we can quickly go over, I don't know, but let
Yeah,
me
you can
download the data.
beginning portion of it. Like,
Sorry?
you can speed through the
Yeah,
questions
because
up to that because we
yes,
did like basically just reviewed that.
yes, yes, I can do that. So in this question, the first thing I will do, I'll say, okay, what is my regression model? This is the thing I have to apply. So what is the independent variable and what is the dependent? So the miles, they want us to do, this is our independent variable and this is dependent. So I'll select this, go to my data, apply regression. And so everything is wrong here. We have to change this.
So the independent variable is always going to be the x.
Yep, X is the independent variable, but it can be here. It can be like anywhere in the data. So we sometime we have to decide like what is independent, but I think in these questions, they're actually telling us. So let X represent the miles. So they're saying, yep, X is the independent variable and is the miles. So I use this miles and I can see these are my estimates or coefficients. All right, so we can plug in these values here. All right, so we'll get this. And then we can talk about this area and how much variation. So again, the variation will come from here, 54% or something, 53.8. So for the model estimated part B, calculate the predicted price and residual of each auto mile in the data. Identify 2 auto miles that were the biggest bargains. If required, round your answer to the nearest whole number. The best bargain is the Camry number in the data set, which has dash miles. Where does it say Camry or something? Does your data set is the same like mine or is it different?
It says miles and price in thousands.
Exactly. Okay.
This bargain is the
So
number.
so
Yeah, it
Camry
doesn't.
Camry number. So there is no names of the cars. It just says this is really weird because this is correct. This is the data set. Okay, so yeah. So let's read the question. Then we will able Twitter is one of the best-selling cars. The cost of the um. All right, so I think. All right, so I think what they want us the best bargain. All right, so here, if you can see, so these are all the 19 observations. These are the predicted price for each of the observation. So starting from here, 1, 2, 3. So all of them, there's a predicted price.
Mhm.
There's a residual. So there's an error. So if which is the best bargain? So if you predict a price which is higher than what is actually in the market, that's a good bargain. Getting my point?
Yeah.
So if
Did
I'm
you
predicting,
mean like predict a price that's lower than what it actually costs?
yes. No, if I'm predicting a price higher, but in market it's much cheaper, I should buy it. because I'm valuing it high,
Okay,
isn't it? That's a bargain for me, isn't it? That's how the bargain concept works. Like I would like if I'm predicting something at a higher value, I should actually go and buy it. But I don't know, like this text is maybe taking a different way. So let's see. But if technically we value things, like if I have to buy something, I will, if someone is selling it for $100 and I predict that this thing values like $200, I should quickly buy it because the
yeah,
100 extra dollar is my bargain, is the profit I'm gonna make. So the error or the negative residual is the profit. So for example, for the first one, the 22, we predicted a price of 15. It's on 16.2, the price.
Mhm.
And for the second, so this is like a positive error. So we are predicting lower, but it's in the market, it's at 16. So if we see for this one, this is a negative. So we are predicting, so on the fourth one, actually this one, it's 47, but we are predicting it's in the market, it's at $11.5 thousand. But here we are saying it's 13,000 predicted price. So that is a good bargain,
Yeah.
what I think. So let's try this number for me. Do you have the same data and same question or different data?
Um, read the read the first like two to four numbers.
Well, you can,
It's 22, 16.2,
okay.
29, 16,
So it's the same data.
36.
Yep.
Okay, yeah.
Yep. So it's the same data set. And I think this thing is different. I think this area. So I think the questions are also same. So, so the best bargain is number 4, Camry number 4,
36
and
miles.
sorry, which has a miles of 47. And for, so it's selling 2 point all this. Nearest whole number. So I'm trying to do a nearest whole number to this area. So I should do it to a nearest whole number. So -2, but there are actually all of them. This is also -2. This is also a -2. So let's keep it at least 2 decimal places so we can see which is better bargain. 2.32, and this is 221. So I think this is a better bargain, number
Yeah.
12. And it has a miles of
28.
28. Yep. And less than its predicted price. So how much it's less? 2. So let me check this because I'm also not sure how they are taking it as bargain. All right, so this is correct, but this has been taken incorrect. Why is that?
Oh,
Do you know what's happening? Like
no,
12?
I thought it would have aligned with slot 13, row 13.
Yeah, that's actually what I thought. So,
Try, no, that wouldn't make sense. It should be
yes.
that number.
So let's create the predicted and let's create the residual here. So we can actually create these columns exactly. So we can do predicted, which is this value plus this value. into product of this value. And then we can actually make this one absolute and this one absolute. So if we don't put this $sign, we cannot drag it down. All right. So this is our predicted prices. And this is the, I'm trying to take a difference of actual minus predicted. And we can drag this down too. So the best bargain is negative 2.3, which is 13, which is 13 actually. No, actually 12 in this.
Yeah, it's just a little weird because the label moves it down
Yes.
one.
It is 28 miles.
Yeah.
So I don't know. So let's try to make it
It's
2
weird.
decimal.
It's
Yeah,
weird how it made it so that 2 is like it said that 2 is wrong also.
2, which 2?
In E, the third thing you entered is just 2,
Yes,
that should also be correct because
that should be correct. Yes. Otherwise, this should be wrong. If this
yeah,
should be wrong. So can you try in your computer? Maybe you'll get a
yeah,
different
yeah. I'll
answer.
try right now.
Yes.
12, 28, 2.
Number 12. So Camry number 12. Okay, let's read the question. We are missing something.
It says 12 is right, 28 is wrong, and 2 is wrong.
It says 12 is right.
Yep. That's weird.
Yeah, that's really weird. Car mileage and sales price for Camry. The following shows the mileage. All right, so 28. Okay, the second best bargain. Okay. All right, so why don't we? All right, let me sort this out. Let's sort it. It will mess up everything, but that's okay. Uh-oh. It's really messed up. Yes, so let me copy this, or we can make it a table. Format as table, okay. Table, and then sort, okay. So based on this is the Camry number. Column 1 is the number. So 228, so this is the best bargain. And the second is this one, which is 447 miles and sell for so we need to get this, or again 2. Yeah, technically this is either we are doing something really wrong, or
Let me try plugging in 2.3 and see if that changes anything.
let's see. And here it was 2.32. Let's see. But they are saying to the whole, maybe not to everything, to the whole number. For the part B, so we calculate in the part B, predicted value and result for each one. Let's do one by one. Like I think we should do this. We should do what's in here. They need 2 decimal places. Okay, so 2 decimal. -6. Oh, 4 decimal. Damn. Just checking one by one to get the perfect answer. All right, so this is correct. So our model is perfectly correct. And the best bargain is Camry number 12. Camry number 12. So that's correct, which
It
has
says that they're both right, like 12 and 4, but then
Mhm.
it's weird how it does that with the rest of the data.
Yes, and which does not make any sense because if
Yeah.
this is correct, then this should be correct.
So,
Yeah,
huh.
that's okay. Let's skip this, ma'am. I will check this manually. I will grade the students manually and check what they have done. I think there is something wrong with the data set or this question. If, yeah, just enter what you find from your data, and then I will manually look at it if it doesn't grade you correctly. But this is homework. This is not the, yeah, but I think you can still get 100% on this one. Because I know this should be wrong. If you're wrong, then this should be wrong in the first place. Which has,
Those are the numbers that match up with it.
sorry?
Those are the 28 and 2.32 are the numbers that match up with 12. So like it should say 12 is wrong if the other two are.
Exactly, yeah. I think it should be 28,000 miles. Get this point?
Oh yeah, because it's in thousands.
Yeah, 32. I think it's like that.
That would make sense.
That would make sense, yeah. So think it's better to, but it's still a guess. We don't know.
Yeah, because it would usually say like to make sure to do that in the problem.
23, 24. And then this would be 4,700 or 47,000. Let's see. So this is, yep. So this is what they actually want. So this was a little bit crazy. All right. So do you know what is this thing?
Supposedly.
And to predict the price. So it's just simply, suppose that you're considering purchasing a previously owned Camry, which has been driven 80,000 miles. So we have to just go and put 80,000 in the formula, technically. So if I put here 80,000, because since I have made my equation, I can just put 80 here and I'll get the answer. So the predicted price should be this one, which should be again in thousands of miles. So this should be again so a whole number will be 767, 11,767. So is the price you would offer, for the seller? So yes. What do you think? This should be,
What's the predicted price? So
because the thing is we don't have the prediction for it.
that's the actual.
No, that's not the actual, because this kind of a car is not in a sample. So we don't, this is like, sometimes it's called out of sample prediction. So we don't have a previous example. So we have no cars which are driven 80,000 mile. So it's a guess. You can take a nearest sample like 78,000 mile or something and see 77,000 mile is around $11,944 predicted. So, yes, so for 80,000 mile, you are predicting less, so that would be a good price to offer. So It's yes. So, and then you can also, talk about the same thing, explanation for the same reasoning that what we just said, because it's still less than for 77,000 mile, what we have the example. So this was question number 3, question 2. Now this is question 3. Were you able to do this? So it's all same. I can see that there are now 3 variables.
Yeah, that's what was throwing me off.
Sorry?
That was throwing me off. So do I
That
have to?
was, oh, was it?
Yeah.
So there is no data set. All right, so this is Dixie Short Movie Theater. So function.
For this
Yep.
one, should I
Mhm.
enter that data manually into Excel?
You can, but I think it's a smaller data set, and then we just need 2 variables. So if you can see, there is a X and there is only Y. So there are 3 total 3 variables, but we just need 2 of them technically. So let's understand this. Use the data to develop an estimated regression equation with the amount of television advertising as the independent variable. So amount of television advertising as the independent variable. So this is the X.
Yep.
Let X represents the, so this variable is X, and if required, round your answers. So what is our Y? What?
Would it be?
They have 8 markets too. All right, so yes, so there are 8 markets. And revenue, I think the revenue is the weekly revenue. You were saying something?
Yeah, I was thinking like, would you try and like subtract newspaper advertising to like just get the television one?
No, I think this is a different variable. This is like X1 and this is like X2, and we have to only deal with X1 at this time.
So newspaper advertising is kind of just like thrown in there, like
Yes, it's just
at this
thrown in
point.
there, and maybe some other students would get a question on this one. Or I don't know, like maybe somewhere else they're going to use this information. So let's see. So I just copy pasted the data here in Excel. And it looks actually a little bit messy, but it's okay for analysis. And I'm just trying to make clear what's in here. Okay, so I have this column, which is, just forget it. Just, I don't know, I don't care. All right. Use the data to develop an estimate regression equation with the amount of television as the dependent variable. X represent the amount of television advertising. If required, round the errors as T decimal for subs or for negative, use the minus sign. So we can just do the same thing. This is our revenue. This is our television advertising. So we can go to data and develop a model. And this is our Y. So Y should be this. And this should be X, which is our X. And then we can place our new data somewhere here. I don't know why my computer is messing. It's just giving me a hard time for some reason. Okay, so this is our two here, I have got two coefficients and there is something wrong going on. So here you can see that instead of the label, I got this.
Yeah.
Let's fix it. So regression. I'm removing the labels so I would know exactly what I have in here. All right, so now it's X variable one. So there is no name, but this is our advertising. And then we can just make it 3 decimal places. So our intercept is negative 40.824 and 40.885. Test for, let's check this. So we are on the right path. So I just want to make sure. No, so this is wrong. 40, okay, yeah, this was 46 actually. So I typed wrong. 46 point. So this is correct. And the significance, sorry?
Would the variation be 51.8?
51.8, yep. And if they're asking it, yeah, 51.80, 52 or 51.80, yep. This will come here.
Would it be 50? Would it be 51.81?
Would 51.81, yes. All right, so now they're saying use the data to develop an estimated regression equation with both television and newspaper advertising. So X1 is for television advertising amount and X2 is for newspaper. So what we just made, we just have one variable X1, but now we have to use the second one too. We can actually easily use Excel and data analysis, regression. Instead of selecting here one variable, we can actually select both of them, like two of them. That's simple, and just reprint it on top of it. So now we have this, so we can enter it here, all three things, and the answer would be correct.
Okay, yeah, I see how that works.
All right, so, and then our variation would be changed. Probably it must have been increased. So it went up to almost 82.14, 92.14. All right, so yeah, I think this is just like, what do you think about part A and C, how the variation went up, and what are the managerial implications? So I think if I have to predict my weekly gross revenue, of course, you should include both the cost, both the advertising amounts, not just one, because we are not even considering the whole stream of income. We're just taking one. And then we should also think about it that the income number one has a higher impact on the revenue, like it has a higher coefficient. So usually in regression, people analyze this just to see the difference. So they both affect the revenue, but you can see the first one is 21.6, so it has more power. And so it affects more revenue. And so this is more important, so that television advertising is more important. So the company should put more money towards television and also use some newspaper to increase the revenue. Any questions on this one, the last one? You're all set?
Yeah, that cleared it up.
Okay. So question number 4, I think it's the same thing. It's the
Same thing, but extended, like another.
More variables. So there are 1, 2, 3, 3 variables. So one of them would be Y. So you have to see which one is a Y. So comfort is X1, amenities is 2, in-house dining is X3,
Overall would be the Y.
overall would be the Y. But here you have to talk about all the tests, significance, and all those things, which are actually coming from here, from this column in that. So we haven't put the data, but so I really wonder, okay, so they actually have given data file. I was thinking, where's the data file? Where is the data file? Too many files in my computer. So I'll close this, enable this. So this is our data, and let's quickly run regression, or you can do this. I don't know, whatever works. Do you want me to go over this section?
You said it's like the 95 percentile for B1, B2, like the estimated regression parameter.
Yes. So
Okay, I shouldn't have to be review that then.
okay, yeah. If you think, let me just see why. So I'm just creating this. No, I have no problem in going over. I'm just asking like if you have time or not.
Oh, I have time for sure.
Oh, you have time? Oh, no problem. Like we can go over. It's like, it's good to go over because those things are actually important. And so this is our regression using all three variables as independent variable and overall as a dependent variable. So these are our coefficients or parameters of the regression. So this is the model, and we can for sure put all of them here. This will give us our answers, but let's see. And what they are actually asking us if these coefficients are actually different than 0 or not. So in regression, I have found this coefficient, but this is on a very small sample. This is like the effect of comfort on overall effectiveness, or whatever this is, the overall uh, quality score. So if someone rates me higher in comfort or amenities or in-house dining, but the real question is, this is, you just have a sample. Does your sample has this much variation, or it can really explains about something about population, because that's what we care about, because this is just a small sample. Even the data of all these people who maybe have graded this hotel, they will not even come back to stay here. But we are interested, like, if we are getting these scores, if someone else comes here, would they have the same feeling? So we are trying to answer the questions for population. And to check that, we usually do a test, a t-test. And the value of the t-test, and then the value comes out of the t-test is the p-value. P-value is the error. If the error is above our set limit, usually it's 0.05 or it's usually 0.01, depending how much error is okay with this. If it's above, then greater than 0.05, we say, actually this has no impact, or this coefficient in reality is 0. So let's read this question. So they're saying use the t-test to determine the significance of each independent variable. So how significant is each independent variable is? What is the conclusion of each test at 0.01 level of significance? So at accepted level of 0.01 error. So they are fine with, because there will be always some error. We cannot make a model which is perfect, predict everything perfect. But they're saying the error is this much, and how does these are really impacting the overall. So we are saying that, is there an effect of comfort on the overall score? And the way to test this is to see the p-value. So the p-value is estimated with the estimated regression parameter B1. So B1 is actually this one, comfort is this one. So I don't know how much they want, 2, 3 level. just makes me crazy. I'll make sure I put 2 significance level because sometimes the answer can be wrong because of that. All right, so the p-value is with the estimated regression parameter beta 1 is this one. So I'll just take this and put here. Because this p-value is less than, it is actually greater than, so this p-value is greater than level of significance. We do not reject the hypothesis that beta 1 is 0. So last time I said what our null hypothesis is the one we actually want to reject. But this p-value shows that our null, which is beta 1 is equal to 0, we cannot reject that because it's above than this level of significance. The error is so much high, like this is the minimum error we can accept, but it's coming out at 0.4, so it's higher than 0.1, so we can reject, we do not reject the hypothesis. Oh, we actually, yeah, we do not reject the hypothesis that beta 1 is equals to 0. So which means that we accept that beta 1 is 0. Getting my point? But in hypothesis writing or theory or research, we never say that we accept hypothesis that beta 1 is 0. We usually frame it in a way that we say we do not reject the hypothesis that beta 1 is 0. We could have said we accept that beta 1 is 0. But no, that is the way to write it. And we conclude that there is not a relationship between the score on comfort and the overall at this level when controlling for other two things. So let's check this answer. Let's run this to get a better picture. What happened? Okay. So yep. So this comes out all of them correct, and the same way all of these would be done. For example, we can do this one. So the second one is about beta 2. So I will put beta 2 values here. I'm just putting the whole thing. So this p-value, its p-value is 0.0000. So it's really smaller. It's less than the significance level. So we should reject the null that beta 2 is 0. So beta 2 equal to 0 means that this variable has no effect on the independent variable. It just means that. So when it becomes 0, so we reject that there is no effect. There is actually an effect. There is a relationship between the score while keeping comfort, and so other twos are keeping, we are controlling just by other twos. And the same thing for the third one. We can say that this one,
I think you put the coefficient for the for B2 instead of the p-value.
oh, I put the coefficients. Oh yes, yeah, I thought they're asking for the coefficient. Yep, you're right actually. Thank you. So this one should also be the coefficient. So it's just, yeah, something. So this will actually come up here. And I'm just, it's actually all zeros. Yeah, almost zeros. So this is also less than this. So the p-value is reject H naught, that beta 3 is 0. We reject this thing. No, it's not 0. The error is really small, so it must have some effect. And there is an overall effect while keeping comfort and amenities as constant. What does this mean, Nida?
All the independent variables.
What does that mean? Remove. So then there will be actually no x1. So I think we have to run the regression again. And in this time, we have to just, so for the last question, they're saying if a variable does not have a relationship, just take it out. So we can actually run regression on these two. And then once the coefficients come out, we can put here and leave x1 as empty and keep x2 and 3 there. So in this way, we can actually answer all the questions. So this one would be 0.
0, yeah.
Yeah, okay. So, yep. So that's how it is. I think the fifth question is very similar to this one. We can find out these things pretty easily from the data. Either you can copy, yeah, so just copy paste in Excel and run it. I think coefficient of determination. So this is coefficient of determination is the R square.
Coefficient of determination.
Yes. Even, I don't know, I'm forgetting. Coefficient of determination. Yep, is the R square, which is the yes, which is the explained variation over total variation. Coefficient is the ratio of explained variation. Yeah, so it's checking the R square. So it's the percentage of variation explained by the model to the total variation. So the same thing we have to test and just talk about it if this is significant or not. So the same thing, the one we did for each of the variables. And interpretation of the variables is same thing. So I can actually explain some interpretation here. So if this is our model, it's generic. So I'm just trying to explain you how regression is interpreted. So if this is our model and we have amenities and in-house dining, so and there's an overall independent variable. So we usually interpret in a way we say a unit increase in amenities a unit increase. So 1 unit increase or 1 point increase in this score of amenities will increase the overall rating by 0.25 times while keeping the in-house dining constant or controlled when in-house is not changing at the same time. So when we are changing 1 unit of this variable, our dependent variable will be changed by 0.252580 times. So that's how we interpret.
Okay.
So it will increase by this amount. So if we increase 1 unit of this, our overall score will increase by 0.25 while keeping in-house dining constant or while not changing the in-house dining at all. So yeah, that's how you usually interpret. So regression is actually the key for a lot of things. And I think as you guys will grow, go to like higher education level, like masters or different thing, you will see regression. For example, this is like I'm trying to write a paper for my research, for my dissertation. So if you see in this empirical work, this is all regression. So it's the same kind of regression we do and trying to make our point and prove it that this thing affects this thing. So yeah, any questions?
Wow. That's a big paper.
Oh yeah, that's just one part. I have to write like three to four papers like this.
Wow.
So this is just one part I have to submit by this 29th of this month.
Good luck.
Yeah. So yeah, if you have any questions, let me know.
Great. You were a big help to get today again.
No problem. Yeah, take care then. Thank you so much.
Yeah, keep me updated on if you're gonna change the class session.
Yeah, so the thing is why I put it in a weekday, because this online course is managed by the Office of Continuing Education. So they have a set guidelines. They have told us we cannot have a chat session on a weekend, technically.
Okay.
Yeah, they want us to do a chat session between Monday to Friday, anytime, and not after 8 p.m. and not in the daytime. So it's really hard. And then I cannot do a chat session on Saturday or Sunday or Friday night, because it's like online students may need a break and they are working all week. So on a weeknight, they don't have time to follow up or come to the chat. But then
It's
again,
just the opposite.
it's just the opposite. And then most of them are working or in weekdays, so they still cannot come. So and then I try to record online session because students cannot come, but and then last time I had a problem with my mic, so I
Yeah, I
recorded
was
the
gonna say
session.
that. I noticed that you did it. There was no audio.
Yeah, I recorded and it was showing that there is an audio, and then because there was no one, so no one can even tell me like there is no audio. So yeah, so it was pretty bad. Yeah, so but I think we will keep it to Thursday, or yeah, or why don't, yeah, I will send an email. So I will send an email if I plan to change. Let me check with the continuing education people. If they say it's okay to make it on weekend, then I will change it on weekend. And if no one has any problem too.
Yeah, if it works for them, that's great. Yeah, I was gonna say I just noticed that like there was either one or two other people in
I
there.
know, but yeah, so I just don't want to change, and then some people can say like, "Why did you change it? We were planning to come on Thursday." You know,
Yeah,
you know,
exactly.
So that's why I don't want to change, because I have no problem. I have to do it on Thursday or Sunday or Saturday is the same thing. Yeah. So all right, we will. Yeah, I'll let you know if we plan to change it on a weekend. All right.
Great, thank you.
All
Happy
right.
Father's
Thank
Day.
you. Thank you so much.